Hello, we're actually doing trig today in trig. I guess we've been doing it all along. But we're going to look at these six trig functions: sine, this is called sine, cosine, and tangent, and the reciprocal functions. The reciprocal of sine is cosine. You'll see that the sine can be figured out by taking the y over the r. So let's think about what this diagram would look like. Let me draw a picture up here. Let's draw a triangle, and let's label the x-axis, that side length x, and this one r as the hypotenuse, right? And that will be y. And the angle theta is this angle that's right here by the origin, okay? That's our theta angle. So if you take the sine of an angle, you want to know what the sine of the angle is, it's the ratio of y over r. So if you know the values of these three things, you can find all these trig functions. If you want the cosecant of theta, it's the ratio of r over y. So we simply need to know x, y, and r, and we can figure out all these ratios. I wanted to point out that the sine and the cosine are reciprocals. Y over r is sine, and r over y, the reciprocal, flip it over, is the cosecant. So sine, cosecant, cosine, secant. That was cosecant, and this is secant. Tangent and cotangent, y over x, x over y, those are reciprocal functions. So we have the reciprocal function. And look over here, that's what they say. The sine is the reciprocal of the cosecant, 1 over this. The cosecant is the reciprocal of the sine. So these are the 6 basic trig functions. They are on your formula sheet, but I really think you've got to know these, right? To get out of trig, you've got to know these. Rock solid. And if you know the 3 basic ones and know which ones are reciprocals, you can find those very quickly. Okay, you'll notice that there is no homework for this 2.4 because that's just to learn these basic ratios. Okay, let's move on to 2.5 where we actually do some applications with these ratios. If you look at the ratios, remember that r is always positive. This tells you the quadrants, the sign, S-I-G-N, where they're positive. So we see that in quadrant 1, everything's positive because you have positive x and positive y and everything's positive. Over here, the x's are negative and the y's are positive. So we have a positive sine and a positive cosecant. So these are the trig functions that turn out to be positive in the different quadrants. Over here you can see x's would be positive, so the cosines are positive over here. And the reciprocal of cosine we said was secant, so the secant is also positive. So this is worth looking at. And let's do the first example. Okay, I've actually worked this out to sort of make it neater. The terminal side of an angle in standard position passes through the point 815. We can think of what that would look like. Okay, suppose we go over 8 and up 15, right about there. And we have the terminal side of an angle going through that. And we form this ratio, and it's 8 over and 15 up. And this is our angle theta right here that we're going to be doing all the trig ratios looking at from that angle right there. And the problem is we don't even know the, oops, went dark, I didn't wiggle the mouse. We don't even know the r here. Having a little trouble with the camera right now. So the r is going to be this value right here, and we're going to find it using the Pythagorean theorem. Well, r is equal to x squared plus y squared. Gosh, the camera's bad tonight. X squared plus y squared. X was 8, y was 15. We do this out and we get that the r, this hypotenuse of the triangle, it's a right triangle, yes, is 17. So really this is a Pythagorean theorem in disguise. That's very frustrating when that camera keeps going out on us. Okay, it wants the 6 trig functions. So we simply work on this. The sine, S-I-N, is the, look up at the top, y over r. So in this problem, x is 8, y is 15, and r is the 17. So we take y over r, 15 over 17. And then we do the cosecant, which is the reciprocal of that. It's r over y, 17 over 15. We do the cosine. Remember, cosine is x over r, so we take 8 over 17 for cosine. And the reciprocal of that gives us the secant, which is r over x, using these values. Tangent is y over x. Get your values, y over x. And then x over y. Okay? So you can see how these just substitute right into those trig functions. Once you know x, y, and r, you've got it made. Okay? It's gone black again, but that's okay because we're turning the page. Okay. Now we want to look at this next practice problem. So go ahead and work it out. The first step is to notice that this is your x, this is your y. Find your r, which r is equal to the square root of x squared plus y squared. Calculate your r. You should get 5. Now go ahead and pause the video and write out your 6 trig functions. Look at the formulas on the page before if you haven't memorized those yet. Sine being y over r. Putting in the numbers to get all 6 trig ratios. Okay, I'm going to uncover those. And you can pause the video and check your answers now. Okay, the next problem. Example number 6. So I'm marking this one. If the sine is negative, remember that's a fancy way of saying the y, right? Because the radius is always positive. We talked about that in the last lecture or so. And the cosine is positive, and we say that's like saying the x because the cosine is x over r, and r is always positive. In what quadrant will it terminate? So we have a negative y. Let's think about this. A negative y could be one of those two, and a positive x. Aha! That's this quadrant over here. That has a positive x and a negative y. So the answer here is going to be in quadrant 4. All right, pause your video and try the next one on your own, please. Okay, we have quadrant. In what quadrant may theta terminate, may it, if cosine is positive? They don't say anything about the sine. That's sort of unclear. We know the cosine is positive. So where would the x's be positive? Well, there would be 2 possibilities for that. The x's are positive over here and here, right, in these 2 quadrants. So that would be quadrant 1 and quadrant 4. Good. I hope you got that. And now we have another example. Suppose that angle theta is in quadrant 2. So that means the x is negative and the y is positive. Okay. And the sine is 2/3. It's positive, and we thought the sine would be positive. In fact, this part is telling us that the y is 2 and the x is 3. Okay. Y is 2 and, sorry, r is 3. R is 3. Then we figure out the x. And in order to figure out the x, I did the Pythagorean theorem. And in quadrant 2, I know that we have to have a negative. So when I take the square root of both sides, I pick the negative square root of 5. I put it in red there so you could see it. The negative square root of 5, because quadrant 2 has a negative x. X is negative in quadrant 2. Now, you know the sine function. That's one of your 6 trig functions. Figure out the others. Well, if the sine is 2/3, then the cosecant, the reciprocal, would be 3/2. That would be the first one I would do. Then I would do the cosine function. The cosine is the x over the radius. So we have a negative square root of 5 over 3. And we have 3 over the square root, negative square root of 5. Now the problem with this is that we can't leave a radical in the denominator, so we multiply by the square root of 5 over the square root of 5. That's like multiplying by a big fat 1. It doesn't change it. So in the numerator, we're going to get 3 square roots of 5 over negative square root of 25. And the square root of 25 is 5. So we have 3 negative, there's my negative down there. Here it's up here in the top all red. We have negative square root of 3 square roots of 5 over 5. So we had to take our answer and rationalize the denominator. I expect our calculators can do that. I'm not going to actually take time to figure that out right now, but you could look at writing this and seeing if it will rationalize it for you. Don't know. Probably would if you knew how to do it. Then we're going to look at the tangent. The tangent is the y, which is 2, over the x, which is negative square root of 5. Then I rationalize that again. This equal sign isn't the most clear. That will equal a negative 2 square roots of 5 over 5 when I rationalize the denominator. Again, I have to multiply 2 over negative square root of 5 by a square root of 5 over a square root of 5 to get the radical out of the denominator. Okay, and that's what I get right there. Kind of squish that in. And then this is the reciprocal of that, so I go to the original one and flip it up, and I put the x over the y, the negative square root of 5 over the 2. Very well. Now ready for you to practice. I may be revealing too much here, probably so. The screen went black, so I guess it's not revealed. Try this one on your own real quick. Okay, if you're done, let's go ahead and look at this. The tangent is the y, so y over the x. And if we're in quadrant 3, think about quadrant 3, here we have negative x's and negative y's. So we put a red negative with the x and a negative with the y. And negative over negative makes a positive. And this tangent was the y over the x. Negative over negative made that a positive 8/5. And I used the r equals the square root of x squared plus y squared to figure out the r, the hypotenuse of the triangle, right? The r for the trig ratios. And that's the square root of 89. Okay, and I didn't show the work on that. You'll need to do that. If you need help, you can ask. Then I made my ratios. So I took the sine, which was negative 8 over the square root of 89. And so I had, my thing may time out, negative 8 over, the square root of 89. It's kind of hard to work when I have to keep jumping my hand down and wiggling the mouse. Okay. So here I have negative 8 square roots of 89 over square root of 89 squared is 89. So that's the answer in reduced form. And there's the cosecant. And I will reveal the last 4 functions here for you. Notice that we have a negative over negative on this one, which makes that a positive 8/5. Negative over negative, positive 5/8. And we can look back to that chart that we had at the beginning that will tell us which functions. It says in quadrant 3, and we're working in quadrant 3, only the tangent and cotangent are positive. See, it says in quadrant 3, only the tangent and cotangent. And we can look at this and see, oh, yep, looks good. In our answer in quadrant 3, only the tangent and the cotangent were positive. Okay, you're now ready to complete all the homework from 2-1 through 2-5, and I will see you in class next week. Goodbye.